With systematic curve sketching out of the way, now we begin to look at the concept of polynomial inequalities. Okay, I mean, we can say that everything we've considered all along is like, solving polynomial equations, equating a polynomial to zero or something, and then solving. But what if we have to deal with inequalities? So the concept of inequalities is the first thing we want to see under that. So let P of X be a real polynomial. We can form a polynomial equation, which is P of X equals 0. That's an equation. Then we can have polynomial inequalities anytime we have any of these possibilities. P of X greater than 0, P of X less than 0, P of X greater than or equal to 0, and even P of X less than or equal to 0. So these objects look similar, but they answer different questions. Okay, equations are different from inequalities for sure. So equations ask, when does the polynomial equal 0? Inequalities ask, when is the polynomial positive, negative, or non-negative? So starting with polynomial equation, P of X equals 0. We've dealt with that a lot of times. So the meaning of P of X equals 0 is this. P of X is 0 asks for all real X such that the polynomial equals 0. These X values are called the roots or the zeros or the solutions of the polynomial. That is the polynomial equation. Then the graphical interpretation is such that the solutions to P of X equals 0 are exactly the x-intercepts of the graph of y equals P of X. And we've done all of that all along. So if P of R is equal to 0, then the graph passes through R, 0. Okay? A very quick way to look at it is, imagine you have x minus 1 into x plus 7. Okay? So centering it here, you see, you have the solutions. It means it passes through. The solutions to this are 1 and minus 7. So the graph passes through minus 7 and 1, like that. Okay? So that's the graphical interpretation of the polynomial equation. Then we now have strict inequality. So strict inequality, P of X greater than 0. It is strict because there's no possibility of equality. So when there's equality, then it's no longer strict. So strict inequality, P of X greater than 0, meaning that if P of X is greater than 0, it asks for X where the output of the polynomial is positive. So here we just need all the values of X that makes the polynomial positive. The graphical interpretation is such that we have P of X greater than 0, meaning the graph of Y is P of X lies strictly above the X-axis. This does not include any X-intercepts. So imagine here now, this is actually equal to 0 as we have it, right? Okay, let me use a smaller number so it doesn't go too far like that. Let's say this is just 2. Equals 0. Boom. What if this now is greater than 0? So we have x minus 1 into x plus 2, and we have these ones right here. Okay, so graph interpretation, like we said, P of X greater than 0 means the graph of Y equals P of X, and it lies strictly above the X-axis. This does not include any X-intercept, like we said already. So, and then we have another strict inequality where P of X is less than 0. The meaning is that P of X is less than 0 asks for all X where the polynomial is negative. So the graphical interpretation is such that we have P of X less than 0 corresponds to portions of the graph strictly below the X-axis. So again, excluding any point where P of X is equal to 0. So apart from the strict inequalities, we also have inclusive inequality, like P of X greater than or equal to 0. So it is inclusive because there's a possibility of equality. So the meaning is that P of x greater than or equal to 0 means the polynomial is positive or 0. So graph interpretation, this includes regions where the graph is above the x-axis and points where the graph touches the x-axis, which are the roots now. Thus, we have above or on the axis. Now, another inclusive inequality is that P of x is less than or equal to 0. The meaning is that P of x is less than or equal to 0 means the polynomial is negative or 0. Graph interpretation, this corresponds to regions below the x-axis, including any x-intercept. Thus, we have below or on the axis. In summary, we have that P of x equals 0 means output equals 0. Graph interpretation, graph on x-axis only, as is just x-intercepts. And P of x greater than 0, output positive, graph above x-axis only. P of x is less than 0, output negative, graph below x-axis only. P of x greater than or equal to 0, positive or 0, graph above or on x-axis. P of x less than or equal to 0, negative or 0, graph below or on x-axis. And then that takes us to know how to graph how the graph solves polynomial inequalities. So solve P of x. So to solve for polynomial inequalities, right, what we need to do is we solve P of x equals 0 normally to find the x-intercepts. Once you find the intercept, these intercepts divide the real line into intervals. On each interval, the polynomial is either entirely positive or entirely negative because polynomials are continuous. So we can then interpret each interval like P of x is greater than 0, so choose intervals above the x-axis. Where P of x is less than 0, choose intervals below the x-axis. P of x greater than or equal to 0, above or on x-axis, which include the roots. And P of x less than or equal to 0, below or on axis, including the roots. So an example of this, we have P of x equals x squared minus 4. So to solve, first of all, we solve the equation, which is pretty easy. So we can see this is difference of two squares already. And that means x squared minus 4 is equal to 0 means we have x minus 2, x plus 2. That means x is equal to plus or minus 2. So these are the x-intercepts. So from the parabola shape now, okay, we can then say P of x greater than or equal to 0 on x less than minus 2 or x greater than minus 2. So, if this is greater than or equal to 0 now, so we're saying that x is greater than or equal, x is greater, the whole thing is greater than or equal to 0. So P of x greater than 0, that happens on x less than minus 2 or x greater than minus 2. Okay, so let's try that. We have x squared minus 4x raised to power 2 minus 4. So already we have these two solutions. So for this to be greater than 0, of course, this brings another kind of science into it, but I think this doesn't particularly work. So, but we know that from here now, this greater than 0 means we have x less than minus 2, So x less than minus 2. Okay. So for the function to be greater than 0, that happens on this axis. Okay. Because here now the curve is totally positive. Then the other side is x greater than 2. Okay. So, but it is only in this region that the function is negative. So what we have done is the function is positive everywhere we have shifted because this other their branches in these regions are totally positive. So it is only here that the function is actually negative. I mean, negative. So the shaded regions are the regions where the function is positive. Easy. And then P of x is less than 0. It is less than 0. That means it is negative. And the negativity is only in this region now. And that is why we say, in this case, it's now that minus 2. So it is negative in that region where minus 2 is less than x, which is less than 2. So only this portion is negative for that graph now. Okay? Then for P of X greater than or equal to 0, for greater than or equal to 0 now, we have, so it will just be what we had up here now. That'll be less than or equal to -2 or X greater than or equal to 2. So let's go back. Go back to what we had before. Greater than 2. Yeah. Less than -2. So now we have less than or equal to. So watch out. Right now, these lines are dashed. So that means that the roots are not part. But if you include equality, the line is now bold. See, this one is still dashed. But if you come here and say equality, so it's now bold. So that means it now includes the roots like that. Okay? So we have the same thing for the other one. So instead of -2 less than X less than 2, to just be, so I'll go back to that. -2, -2. Okay, I mean, X squared minus 4 is already what we have here. So we now have -2 less than X less than 2. So you can see that as negative, but you can see the lines are dashed, meaning that it is excluding -2 and 2. But to include -2 and 2, once I say equality now, the dashed lines are now solid. 2 now solid. Okay, so that takes care of that idea. Okay, so X squared minus 4, trying to see something. So X minus 2 is greater than 0. Okay, X minus 2 greater than 0. That means X is 2. X plus 2 greater than 0. So that's X greater than. Okay. So now here we see that this demonstrates clearly equations give you the points while inequalities give you intervals. Okay, so we have some practice questions right here. So imagine this particular one, X minus 1. Okay, I mean, this one just looks like what we had done already. So if you try X squared plus X minus 6, so X squared plus X plus X minus 6. Okay, we don't have this. Yeah. So we see these two solutions, -3 and 2. So you can clearly see that this equation is positive for two conditions. When X is less than -3, -3 is where it crosses here. So when X is less than -3, okay, so that the branch there is positive. Then the other branch where it is positive is where X is greater than 2. Okay, so that goes. Then for negative, this is the branch where the function is negative, this branch. So that means -3 is less than X is less than 2. So that branch is negative. Then what if when the expression is greater than or equal to, so that'll be what we did before, X is less than or equal to 3, I mean -3, all right? So now the line is solid. Then the other time we also had X greater than 2. So but now we want it to be inclusive, that is greater than or equal to 2. Then lastly, we can also have X less than or equal to 0. So we have, that means we have -3 less than or equal to X less than or equal to 2 to X less than or equal to 2, like this. So that portion. So that kind of thing. Then here now we have X minus 1, X plus 2, X minus 4. So we want to find for less than 0, where the function is actually where it is negative. Now, I think there's a particular pattern I have been seeing. So where the root is negative, so you need to do less than that root to have the function to be positive. Let's see how this goes. So, and where it is positive, we have to do greater than that to have it negative. So let's to have it positive, greater than it is positive. So let's see. x minus 1, x plus 2, x minus 4. X minus 1, x minus 1, x plus 2, x minus 4. Okay, so we have this now. Minus 2, we have 1, and we have 4. Now you see, we have two positive roots and one negative root. So for this function to be positive now, so look at what happens. For the negative one, it has to be less than minus 2. No, this doesn't work. It is negative in this case. No, this doesn't work. So here now, you see that part is actually negative. So, okay, what we actually want is the expression less than 0, okay? Less than 0. So in this case, this doesn't work. So what we are going to do here is, so if you look at it, so I'm still thinking of an empirical way of getting this, or I guess it's maybe the easiest. I'm thinking of an empirical way of getting this out. Mm. But I mean, from here now, we know that for x less than minus 2, the function is negative for sure. So since we are looking for negative, so x has to be less than minus 2. So what I said initially would not hold here. Okay. So x is less than minus 2, it is negative. Then we also have that between, so it's negative there. And then the other negative part is from this other point now, this 1 and 4. So it's like 1 less than x less than 4. So that portion is also negative. Elsewhere, it is positive, as you can see. Okay? So it is negative in all these regions now. That x is less than minus 2, and from x1 less than x less than 4. So it looks like it's best to sketch the curve to get it. Mm. So it is based on the shape. It is basically based on the shape. So you need to get to do a great job, you need to be able to sketch and do that. Okay, before I go, I want to solve number 8. Okay, I want to solve number 8. Number 8 says solve the inequality x minus 1 cube. That's x minus 1 cube plus x minus 1 squared greater than or equal to 0. Okay, x minus 1 cube. So x minus 1 cube plus x minus 1 squared greater than or equal to 0. So here now, of course, x minus 1 is common. So x minus 1 into x minus 1 squared rather into one of this. That's x minus 1 plus one of this greater than or equal to 0. So that means x minus 1 squared into x minus 1 plus 1 is greater than or equal to 0. So that means we have x minus 1 squared into x greater than or equal to 0. That means x into x minus 1 squared is greater than or equal to 0. So in this case now, like we know, the first thing we want to do is to solve. So we solve first of all, x into x minus 1 squared equals 0. We have to solve that. So that means we have x equals 0 or x minus 1 squared equals 0. So that means x is equal to 0 or x is equal to 1 with multiplicity of 2. Multiplicity of 2. Multiplicity 2. Okay, so x is 0 and x is 1. Okay, but we want this whole thing to be greater than or equal to 0. So it is always good to have an idea, you know, of a sketch of this now. We already know how to sketch stuff, right? But I mean, the easier way is to just, let's go to graph x into x minus 1 squared. Okay, like here, x into x minus 1 squared. So x into x minus 1 raised to power 2. So we have this right here. Okay. So now you see if what exactly where it is greater than or equal to 0. So it is only greater than or equal to 0 between 0 and, I mean, yeah, it is greater than 0 where x is greater than 0. That's all. That's where that function is greater than 0. Easily. Based on the plot. Okay? So, so where x is greater than or equal to 0, then that expression is always greater than 0. The other part is x is greater than or equal to 0. This is greater than or equal to 0. So it means that their product is greater than 0. So x is greater than 0 simply. Okay? So it is guaranteed here for x greater than 0, this expression is always like this. But for less than 0, that would just be x less than 0 too. So it just flips over to the other side. So I think that just goes. So that x determines what happens in this situation. So let me see if I can try another question. Hmm. Okay, it says determine all real numbers x for which the graph of y, which is minus x raised to the power 4 plus 2x squared, lies above the x-axis. Lies above the x-axis. So minus x raised to the power 4 plus 2x squared minus x raised to the power 4 minus x raised to the power 4 plus 2x raised to the power 2. Okay, so the question again is determine all real numbers x for which the graph of y, this lies above the x-axis. So we see here that there are two, okay, yeah. In fact, how do I put this? I'm trying to see. So this should be like minus 2 greater than or equal to x greater than or equal to 2. Okay, that doesn't work. Everything is still involved. So we have to do it in portions. Okay, we have to do it in portions. So it's like minus 2 greater than or equal to x. I mean, less than or equal to x, less than 0. That doesn't still work. This is interesting. That doesn't work because we still have a negative component of this. Above the x-axis is what we are interested in. So, what should that look like now? Trying to think of this. Okay. So maybe some solving may be necessary. Minus x squared plus 2x squared minus x squared. So it's not straightforward. Minus x squared, I think. Minus x squared plus minus x raised to the power 4. So that's minus x raised to the power 4 plus 2x squared equals 0. So we have 2x squared minus x raised to the power 4 equals 0. That's like difference of two squares now. Okay? Lies above the x-axis. That is y is greater than 0. So y is always greater than 0. So here, so that means this function is positive in short. So here we have what can we have here? So we have x squared into 2x minus x squared. X squared into 2 minus x squared, yeah, equals 0. So x squared is 0 or 2 minus x squared is equal to 0. So x squared is equal to 0 or x squared is equal to 2. So x is equal to 0 twice. X is 0 twice, okay? Or x is equal to plus or minus root 2. X is plus or minus root 2. So we have two things to work with here. X is plus or minus root 2. So minus x raised to power 4 plus 2x raised to power 2. So of course, from the graph, clearly we see this. So the whole thing happens within this region. So let's see. If we say x is greater than square root of 2, square root of 2, okay, that doesn't still work. What about minus? Okay, what if we now have now we can see the reality, but then I need to get it into a kind of expression that works. So less than this. Yes, I think we finally have it. Yeah. Okay, I think this is what we're looking for. So, the all real numbers x for which the graph of y minus x raised to power 4 plus 2 squared lies above the x-axis. That'll be okay. So that's actually the region. So I can conclude here that all real values of x, all real values, all real values of x. Okay. So minus x raised to power 4 plus 2x squared lies above the x-axis for x uh when minus root 2 is less than lies above, right? It's less than x, which is less than root 2, basically. So this is what we have here based on the plot. So it's not just about just saying something greater than 0 like that. So this is what happens in this situation. So minus root 2 less than x less than root 2. So that means x is greater than minus root 2 and x is less than root 2 itself. Yeah, I think we're good with that. All right, so you want to try your hands on the other questions and see how things go. So let me know how helpful this is for you. If you have subscribed already, I say thank you very much. If you haven't subscribed, of course, you want to go ahead and subscribe right now. Having done that, you can also become a member of this channel by clicking on join, and that gives you some special privileges. Okay. Ultimately, don't forget to comment, like, and share so that you can have so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.